Right now, the NOAA Space Weather Prediction Center has active watches in place for a massive geomagnetic storm approaching Earth. According to their latest forecast, the Aurora oval is dipping unusually far south. The view line drops straight down into mid-South Dakota, putting 10 contiguous northern states directly in the impact zone. For millions of Americans living in these lower latitudes, the northern lights are a phenomenon you usually have to fly to Iceland or Alaska to see. This weekend, the event is coming to them. The severity of these events is measured by the Planetary K-Index, or KP, a scale from 0 to 9 tracking fluctuations in Earth's magnetic field. The forecast predicts sustained activity peaking at a KP of 4.67, pushing it firmly into moderate storm territory. This incoming invisible wave of magnetic energy creates a rare window for millions of people to step outside and watch our atmosphere react. To catch it, you have to know exactly what is about to hit us. The origin of this light show sits 93 million miles away. Our sun operates on roughly 11-year periods of magnetic activity, and we are currently at the volatile peak of solar cycle 25, the specific time frame when sunspots and solar storms are at their most frequent. Earlier this week, a highly active region known as sunspot 4366 rotated into direct alignment with Earth and violently ruptured. That flare triggered a coronal mass ejection, an enormous release of plasma and accompanying magnetic field from the sun's outer atmosphere. This billion-ton cloud of superheated gas immediately accelerated away from the sun, tearing through space at over 600 kilometers per second. It has now crossed the vast vacuum of the inner solar system, and that exact cloud of plasma is on a direct collision course with our planet. Under normal conditions, Earth defends itself. We're enveloped by a magnetosphere, a massive shield deflecting deadly solar wind. But right now, we're experiencing the Russell-McFerrin effect. Near the spring equinox, Earth's magnetic field aligns with the solar wind, creating specific vulnerabilities in our armor. Through those seasonal cracks, high-speed protons and electrons from the coronal mass ejection bypass the shield. They get caught in our magnetic field lines and are instantly funneled down toward the polar regions. Because the North Magnetic Pole currently sits offset in the Canadian Arctic, the resulting auroral oval is pushed disproportionately south over North America, reaching much deeper into the US than it does over Europe. At an altitude between 80 and 300 kilometers, these trapped solar particles slam into atmospheric oxygen and nitrogen gases. The collision violently excites the atoms, transferring massive amounts of energy. As those atoms return to their normal resting state, they release that absorbed energy as photons. The sweeping green, red, and purple ribbons we call the northern lights are simply the visible exhaust of a high-altitude chemical collision. That specific high-altitude chemistry is exactly what the NOAA space weather models are predicting for this weekend, translating directly to that KP index of 4.67. For observers on the ground, a storm of this magnitude means the aurora will clear the northern horizon in states like Montana and Wisconsin. But for those further north, in Minnesota and North Dakota, the vibrant displays could easily be directly overhead. To actually see the reaction, you need to eliminate competing light. You have to get far outside city limits and escape local light pollution and find a dark location with a completely unobstructed view to the north. Once you are there, put your screens away. The human eye requires at least 30 uninterrupted minutes in the dark to fully adapt. Even a quick glance at headlights or a text message resets the clock, rendering the subtle auroral glows completely invisible to you. If the colors look faint to the naked eye, modern smartphone cameras have a distinct advantage. Their image sensors accumulate light over a few seconds, easily capturing vibrant greens and purples that your retina might miss. The geomagnetic activity is forecast to peak late Saturday night. The prime viewing window for optimal darkness and storm intensity sits right between 10 p.m. and 3 a.m. local time. 1 billion tons of plasma has traveled 93 million miles, slipped through a seasonal crack in Earth's magnetic armor, and ignited the upper atmosphere. All you have to do is step outside, look north, and watch the impact.